Okay.
Okay, we have a dozen now, and we'll, I'm sure, pick up some more. But I might start off, even though it's a minute or so to 10, just by introducing our speaker this morning. Marcia Bjornerud, is that correct pronunciation? Good. She is professor of geology and environmental studies at Lawrence University in Appleton. Her research focuses on the physics of earthquakes and mountain building. She contributes field-based studies of bedrock geology with quantitative models of rock mechanics. And she's done research in high Arctic Norway, Svalbard to be specific, as well as Ellesmere Island in Canada, and mainland Norway, Scotland, New Zealand, and Lake Superior. She teaches courses ranging from hard rock, that's not the musical type, and planetary geology to environmental modeling and history of science. She got her bachelor's in geophysics from the University of Minnesota and her master's and PhD in structural geology from here at UW Wisconsin in Madison. She's founding director of Lawrence's degree granting program in environmental studies. And she was named Outstanding Educator in 2011 by the Association of Women Geoscientists. She's the author of a well-received book, Reading the Rocks, the autobiography of the Earth, and a contributing writer in the New Yorker's science and technology blog, Elements. And I was, just to give you a little insight into how I heard about Dr. Bjornerud, is I happened to find her book at the local bookstore. And I was intrigued by the title, particularly the subtitle. The title, of course, is Timefulness, but I like the subtitle, How Thinking Like a Geologist Can Help Save the World. And so I'm looking forward to that explanation, and it will sure to factor in any questions that I and some of you might have. So I really look forward to listening to you talk. Marcia, I was thinking of trying to summarize your talk, as I did, if I've done from some other authors. A year ago, I tried to do one on the grid and invited the author, and that worked out extraordinarily well. And I'm so glad I thought of doing the same with you, because I couldn't do your book justice. We really need to have the author to do this. It's a very, I think, for someone who's only had an introductory course in geology about 70 years ago, it's a mind-grabbing theme, and it really requires paying attention and thinking three-dimensionally. So I'm looking forward to how you handle it as a teacher. So you have the floor. Thank you for coming.
Thank you, Richard, and hello, everyone who I can't see out there. I thought we could start by just having a kind of free association with the term geology. Could people either maybe in the chat or just, I'm not sure how you usually do discussions, if you could just call out or raise your hand, and then what do you think of when you think of geology?
You're welcome to speak auditorily. Otherwise, I can look at the Q&A for any questions that you want to type in.
I see Sherry says the study of Earth and its forms, great. Again, free associate. Continental drift, okay. This is clearly an enlightened group. Rocks and how the Earth evolved. Can't argue with that. Many people, just to sort of, I guess, be the devil's advocate here, many people, when I say I'm a geologist, say, oh, are you in the oil and gas industry? Okay, Kathy Berman, exactly. Do you dig, or they get it conflated perhaps with archaeology, or they think dinosaurs is the first thing that occurs to many people, or mineral exploration. And all of these things are components of geology, or More commonly these days, we say the geosciences. And geology has produced many commodities for humankind: coal, oil, gas, metals, groundwater, and admittedly not in the most environmentally friendly ways. We have certainly, we are culpable for many environmental sins as geologists. But I want to convince you today that perhaps the most important commodity that geology has ever produced is a sense of deep time. I'm going to share my screen. Oops, play. So I'm hoping everyone's seeing my screen now.
Yes.
So the geologic timescale, our map of deep time, is truly one of the great intellectual achievements of humankind, but underappreciated since it wasn't the work of a single solitary genius, but the result of 2 centuries of work by legions of field geologists, paleontologists, and geochronologists from all over the world, from many cultures and traditions. And as I said, it's taken at least 200 years and it's still a work in progress. For me and other geoscientists, the geologic past feels almost like a spatial dimension. So Richard said we need to think in 3 dimensions. I would argue that we need to think in 4 dimensions, with that 4th dimension truly being time. We routinely think in 4 dimensions. We almost can't help ourselves. So here's a lovely place that I've been on a field trip. It's in the southwestern part of the UK. It's a famous place called Hartland Key. We can all enjoy it aesthetically, but as a geologist, I can't help myself but start disentangling the story of this place in time. In the background here, we can see cliffs that are eroded by modern processes, but they're unveiling stratified sedimentary rocks that themselves have been tightly folded. We can see multiple levels of eroded surfaces that record different stands of sea level. So even the most casual glimpse of a landscape to a geoscientist is a record of time. And so what I want to instill in you today is some appreciation of that habit of mind and how powerful it can be as we try to become more enlightened about how to be Earthlings on a really old and complex planet. So this is what I mean by timefulness. It's an awareness of the rich natural history that envelops us, but it's not just backward looking. It's a sense that we too live in geologic time and are part of a continuum from the planet's past into its future. Timefulness, which I think is a word I coined, at least in this context, is a deliberate counterpoint to timelessness, which we might think we would like, things never to change and remain as they are in perpetuity. But timelessness, I would say, is an unattainable, sterile, and even dangerous idea. But confounding our efforts to be timeful is the fact that we live in a time illiterate society. We would be shocked if an educated adult had no idea where the continents were on a global map, but don't seem bothered by the fact that few average people have a good sense of the geography of the planet's past. Even though we will spend our entire lives here, too many Earthlings behave like bad tourists on the planet, enjoying its amenities and ransacking its bounty without ever having noticed that it has its own ancient language and customs. And as I've already suggested, many of the environmental problems we face have arisen because the public lacks a sense of the durations of chapters in Earth's history, the rates of geologic processes like groundwater flow, or the intrinsic timescales of phenomena like climate change or mass extinction. In our culture, time denial, or what we might call chronophobia, is rampant and comes in many varieties arising from different sources. If we as geologists seek to dispel time illiteracy, it's important that we understand its origins. The most obvious and vocal opponents of deep time are, of course, young Earth creationists, but it's worth noting that 200 years ago, geology and theology were not at odds. In fact, the discovery of deep time, to use John McPhee's evocative phrase, was actually motivated by religious belief. So anyone who's had an introductory course in geology may recognize this very, very famous outcrop. It's called Sycar Point. It's just on the border between northern England and Scotland on the east coast, near the town of Berwick. And this is the place, at least in Western science, where the idea of the antiquity of the Earth was really recognized. The beginning of modern geology as a discipline is usually traced, and I think appropriately, to a Scotsman named James Hutton, who was a physician, gentleman farmer, naturalist, and polymath on the fringes of the Edinburgh Enlightenment. He often drank and dined with the likes of the philosopher David Hume, the inventor James Watt, economist Adam Smith, and apparently Ben Franklin even visited him once. As a landowner, Hutton was concerned for economic reasons that the large amount of soil he could see was being washed to the sea every year. He owned land near this area on the east coast of Scotland. But as a religious person, a deist like many Enlightenment thinkers, he was also troubled spiritually by the idea that God would simply allow the earth to be worn steadily away, that sometime in the future, all of the continents would be eroded to sea level and the earth would be uninhabitable by humans. So his writings suggest that he was actively looking for evidence of some compensatory process of rejuvenation that would counteract erosion. And he found it late in his life at this rocky promontory off the east coast of Scotland, Sycar Point. So what we see here in the rocks are two sequences of rocks, a sort of slightly pinkish, planar or nearly horizontal sequence here. And these are overlapping on a nearly vertical sequence of stratified rocks here. So it's a little bit of a complex contact, but I'm tracing it out with my cursor, if you can see that now. And what Hutton recognized was this contact between these two surfaces represented the time it would have taken for a mountain belt to be eroded virtually to sea level. So he recognized that this older sequence of rocks standing on end were the eroded remnants of what we would call tectonically deformed rocks that had been folded and tilted, representing a mountain building episode. And then erosion had happened to the point where a completely new series of rocks were deposited on top. And this type of contact is called an unconformity. It represents a surface of erosion, or at least non-deposition, in this case, profound erosion of a mountain belt. And Hutton very astutely, in a time when the field of geology was not really a distinct science, recognized that this was an immensely long period of time, certainly far longer than the 6,000 or so years allotted by a literal reading the Bible. And he famously wrote, "He grew giddy from glimpsing the abyss of time." And this was the beginning of the recognition that natural timescales were unfathomably longer than human understanding of time. And I might just mention, since we're all in Wisconsin, that at Devils Lake State Park, I'm sure many of you have been there, we have a really profound unconformity exposed there between the Baraboo quartzite, which really makes the Baraboo Hills, and the Cambrian sandstones, which are exposed throughout the Madison area and throughout southern Wisconsin. And that unconformity represents about 1 billion years of erosion. Hutton's unconformity, as important as it is for the history of science, only represents about 60 million years of erosion. So our unconformity at Baraboo is far more profound in some ways. Anyway, Hutton gave us deep time, but he wasn't particularly interested in the granular details of what precisely had happened during those vast eons. So Hutton actually had this idea of an infinitely regenerating Earth. I should have mentioned that too, that this was part of his whole philosophy that he had largely developed apart from actual field observations. He thought that the Earth was in some way a kind of cyborgic machine that had an internal heat engine. And he was correct in a sense that the Earth's internal heat could cause upheavals in the crust and cause mountains to grow. And then there was the powers of erosion at the surface. And he saw this particular outcrop as just a representative of one of many, many, many cycles of mountain building and mountain destruction, this ongoing process of renewal and dismantling. And famously, another quote from him is that the result, therefore, of our present enquiry is that we find no vestige of a beginning and no prospect of an end. So he actually posited that the Earth was infinitely old and would have an infinitely long future. So Hutton's beautiful idea of an Earth that was infinitely old and continuously regenerating captured the public's imagination in the way that space exploration does in our time. So here's a popular depiction of Hutton's unconformity with the vertical rocks and then the stratified rocks on top with this rubbly layer representing that unconformity, that immensely long period of erosion. And then this is the modern landscape, at least in the early 1800s, on top. So this was really a powerful idea that was, it made inroads into public consciousness at the time and ignited public interest in the emerging science of geology. In the 1830s, British geologist Charles Lyell published his great treatise, Principles of Geology, which also really entered the public consciousness. It was a bestseller in both the UK and the US. And even Mark Twain has a funny passage in Life on the Mississippi describing a grizzled old riverboat captain who had a copy in his pilot house. Again, Lyell's book, like Hutton's work, did not seem to have created a schism within the church at the time. I'm not a scholar of religious history, but this suggests to me that in the era, this early 19th century time, the timescales in Genesis were generally accepted as metaphor rather than literal truth. It really wasn't until paleontology began to uncover evidence of extinct creatures and vanished ecosystems, and of course then when Darwin suggested how organisms, including humans, could have evolved through the non-directed process of natural selection, that the church began to see geology as a threat. And I want to acknowledge here that many other cultures around the world probably did not have the same aversion to deep time and the idea of biological evolution that the Judeo-Christian West has had. But I focus here on the European tradition because that is in fact where modern geology and the calibration of deep time got its start. Anyway, at this point in the 21st century, geology has been contending with creationists and young earthers for more than 150 years. And it's easy to be derisive about young earth thinking, but I do empathize with people who are truly struggling to reconcile their religious beliefs with scientific understanding. I occasionally have students who are in this position, and I offer them a variation on an argument made by the philosopher René Descartes in his Meditations on the Nature of Reality. Early in an introductory geology class, one begins to understand that rocks are not nouns, but verbs, records of processes. This limestone reflects the accretion of a coral reef, or that garnet schist, the growth of a mountain belt. So I ask these students to consider, which is more heretical, to accept the idea of an old and evolving Earth set in motion 4.5 billion years ago, whose internally consistent history, a remarkable, awe-inspiring saga, has been worked out little by little over the past 2 centuries by people from many cultures, or a deceitful creator who has planted false clues about the planet's past in every nook and cranny, from fossil beds to zircon crystals we may one day analyze, just to mislead us. And I let students decide for themselves. But I have no patience for the aggressive misinformation, the awful mashup of biblical literalism and alleged science that is posted online by the Institute for Creation Research and turned into lucrative business ventures at places like the Creation Museum in Kentucky, which has this huge Noah's Ark exhibit. To those who actively distort scientific facts and fog the brains of young earthlings, not to be confused with young earthers, I would say, okay, then live with the implications of your worldview. You won't have access to fossil fuels since the gas in your car was found by geologists with an understanding of the stratigraphic record. Likewise, modern medicine is off limits since much of it is based on testing on mice, which only makes sense if you understand that they are our evolutionary kin. Apocalypticism is a dangerous offshoot of religiously motivated time denial in which not only the geologic past, but also the future are foreshortened. If you think there is no future, then there's no need to conserve or be concerned with climate change. In fact, not using up resources is paradoxically wasteful. But again, young earthers are at least completely open about their aversion to time. More insidious forms of time denial are woven into the very fabric of our culture. Our natural existential dread of aging and death has become entangled with vanity through capitalistic messaging in a society obsessed with youth. As a result, we fear and loathe our timiness. Making us afraid of time is big business. Time denial is a multi-billion-dollar industry. At least this product is completely forthright about being detached from reality entirely. Have you noticed that these days we more often refer to ourselves as consumers rather than citizens? And that doesn't really seem to bother anyone. Citizen implies living somewhere over time in proximity to others with the attendant give and take that requires. Consumer suggests only taking, as if our sole purpose were to devour everything in sight now in the manner of locusts descending on a field of grain, with no thought for the consequences for the future of society. And we are all as insatiable as locusts for novelty, the newest smartphone, the just released app, the meme of the moment, the latest elixir of life. We don't notice how quickly all of these age, become old, tired, so 5 minutes ago, because the next ones arrive to take their place before we have a chance to dwell on that, allowing us to remain pleasantly distracted in a never-ending now. This narcissistic preoccupation with our own creations has led to a mass illusion that we've outgrown the natural world. In this country in particular, there's a widely accepted notion, a virtual credo, that free markets represent an almost sacred natural state, that anything that fetters them, including protections for nature itself, which provides the raw goods for those markets, is unnatural. And while we may scoff at apocalyptic thinking, the opposite view that we can carry on forever at ever increasing levels of resource consumption is equally deluded. But it must be acknowledged that science itself is culpable for other strains of time denial. In the hierarchy of sciences, it is telling that the pure, that is timeless, eternal ones, physics, and maybe also chemistry, are most esteemed. Biology and geology, which reek of time and history, are by implication impure. There's no Nobel Prize in geology, though there is one in economics. I respect the accomplishments of the other sciences. Geology is in fact a highly interdisciplinary field that necessarily draws on the principles and methods of physics, chemistry, and biology. But many environmental problems we face are the result of the failure in the early to mid 20th century to anticipate how new technologies, the internal combustion engine, chemical fertilizers, antibiotics, plastics, would interact over time with complex, evolving natural systems. The scientists and engineers behind these innovations could have used a bit of geologic thinking, some timefulness. An unfortunate reality is that the unintended consequences of our technologies will almost always outlive our intentional implementation of them. To think geologically is not as much about time itself as the power of time to inexorably alter, entangle, magnify, ramify, complicate, and otherwise transmogrify. But geology too, as a discipline, has been at fault for failing to put human and planetary timescales in proper perspective. First, for a variety of reasons we could talk about maybe in the discussion, geology is a bit of a late bloomer. It's pretty embarrassing for us to admit that the laws of thermodynamics were worked out in the 19th century, the structure of the atom in the early 20th, but plate tectonics, the way the solid Earth works, was not figured out until 1965. Some of the delay was technological. Earth was too close and too big to see clearly at that time. But it was also partly due to the myopia and lack of imagination of the majority of geologists in the early to mid 20th century, who were for various reasons not able to see the Earth as a dynamic planet that was continuously reconfiguring itself. The relatively late maturation of the geologic sciences haunts us today. In the early 20th century, as high school science curricula were becoming standardized, geology was not yet a rigorous discipline. It lacked a coherent conceptual framework, and it was left out. As a result, we have generations of Earthlings, including very educated and powerful people, and even most trained in other sciences, who have never had the most basic introduction to the geosciences. This is an unfortunate happenstance of history, and we as geologists need to work together to advocate for more geoscience in the schools. But another ironic reason for public time illiteracy is that in some ways, we geologists have been too emphatic about the immense antiquity of the Earth and the slowness of geologic processes as a result of our constant vigilance against young Earthers. I'm sure you're all familiar with this clock analogy for geologic time, that if all of geologic time, the 4.5 billion year history of the Earth, were one 24-hour day, we humans would have appeared just in the last fraction of a second before midnight. And this is literally true, but I think it's wrong-headed in a number of ways. First, it's alienating. It suggests we appeared out of nowhere and denies our deep roots in the evolutionary past. We humans in present form are relatively recent arrivals, but our ancestors have been here since the early morning hours. And it seems to absolve us from responsibility for our actions. How could anything we've done in the last fraction of a second matter to the Earth? Also, as all of you know, Earth is really not so sluggish. It has many tempos, moods, and modes, sometimes moving too fast for us to keep up with. And there are unfortunate asymmetries in the rates of processes. Evolution is slow, but extinctions can be brutally sudden. Sliding into an ice age is generally gradual, but warming is very often abrupt. Groundwater accumulates for centuries or millennia and can be depleted in years. Geology is a strange hybrid of the pragmatic and the philosophical. It's about where to find oil or groundwater, how to protect people from natural hazards, but it's also about deep existential matters. Where do we come from? Why is the Earth the way it is? What factors favor stable, resilient ecosystems and societies? And it's as much about the future as the past. In 30 years of teaching and talking and writing about geosciences, I've tried to come up with ways to help people with no previous background in our field to start thinking like geologists. One apt metaphor is that of a palimpsest text, like this one, the Archimedes Palimpsest. In medieval times, texts were often written on parchment, a commodity that requires a lot of labor to produce. And so they were often scraped of the ink and then written over again and reused sometimes several times. But always vestiges of the older text would remain beneath the most recent text. Similarly, landscapes have their histories written all over them, scraped by erosion and overwritten many times. Once you become attuned to the earlier scribbles, it's almost impossible not to see them. I often feel that I don't just live in Wisconsin, but in many Wisconsins. There are the forests still recovering from 19th century clearcutting. There are the Great Lakes and mighty rivers that governed ancient trade routes long before Europeans arrived, legacies themselves of the immense ice loaves that flowed down from Canada. There are the golden Cambrian sandstones marking the shores of long vanished seas. The banded iron formations, steel gray and blood red, recording oxygenation of the atmosphere. And in the north, contorted gneisses that are the roots of Proterozoic mountains. Of course, every place on Earth has similar stories, sprawling, multi-generational sagas of stability and upheaval, seas rolling in and out, glaciers advancing and retreating, mountains rising and being erased by erosion. Understanding those histories is a bit like learning the etymology of a word or phrase. One has a rush of insight as suddenly a window is opened onto an earlier time. It's almost like remembering something long forgotten. I think it's important to acknowledge that some people feel diminished by geologic time, that humans are made insignificant by it, and I understand that. But I think it helps to start developing some depth of field in thinking about time. I had a math teacher once who was fond of saying, there are many sizes and shapes of infinity. Some things, like the Pleistocene, the Ice Age, happened just the other day. Others say the formation of Pangaea a while ago, and some, the origin of life, a long time back. Geologic time is not infinite, but in some sense, I think this idea that there can be different amounts of deep time is useful. It's also helpful to adopt the Greek distinction between chronos, raw time, billions and billions of years, and kairos, which is time within a narrative. As one starts knowing Earth's history and the vast stretches of geologic time are filled with narrative, protagonists, and plot lines, it's no longer alienating. The characters become familiar, the themes resonant. Once we open a few volumes in the Library of Deep Time, we can begin to recognize ourselves in the tales of earlier Earthlings. Indeed, I find the idea of a 6,000 or 7,000 year old Earth with a short, shallow story positively terrifying. while the enveloping presence of so many ancestors with such a rich anthology of life stories to recount is, to me, deeply comforting. One of the most important lessons of the rock record is the centrality of balanced biogeochemical cycles to the long-term habitability of the Earth. The message is, be loopy, dance endlessly around in circles. That is, recycle. Other than a fine rain of comets, micrometeorites, and the occasional dinosaur-killing asteroid, Earth has not acquired any significant new mass since it formed 4.5 billion years ago. Yet the median age of continental surface rocks is only about 500 million years. The oldest ocean crust is only 170 million years old. The oceans themselves are refreshed every few millennia. And as Hutton pointed out, soil is constantly washed to the sea, but so far hasn't disappeared entirely. This means that everything on the planet is incessantly recycled, reforged, and restocked. The water, air, soil, the very crust of the Earth at vastly different rates via evaporation, precipitation, oxidation, reduction, subduction, metamorphism, melting, and crystallization are reused, reacted, and remade. Every process has an inverse operation, every flow a compensatory counterflow. It's like an elaborate contradance happening across many spatial and temporal scales in which after many, many rounds, everybody ends up back where they started. In fact, this tendency for infinite repetition and reinvention is the single most important attribute that distinguishes Earth from its sister planets. It's not simply that Earth happened to be the right size and distance from the sun, but that it developed habits as a young planet that it has kept its surface environment stable for most of the past 4 billion years. Life on Earth got involved in that circular logic very early on. But it's also sobering to note that all of the great mass extinction events of the geologic past, have been linked with severe disturbances to the carbon and other biogeochemical cycles. And this is a super busy slide and maybe something that we could come back to at the end. It's from one of the appendices of my book, but it's just underscoring the idea that most of the really severe ecosystem disruptions, including the 5 great mass extinction events, have ultimately been connected to disturbance in biogeochemical cycles, especially the carbon cycle. Even the dinosaur extinction event that was, of course, caused by an asteroid hitting the Earth ultimately led to biogeochemical disturbances, and that was really the proximal cause of the extinction. And the bedrock story of the greatest mass extinction of all, the end Permian extinction, far, far more severe than the dinosaur extinction, which only ranks number 4, tells how a thriving global biosphere was dealt a nearly mortal blow by the combined effects of abrupt volcanically induced greenhouse warming, ocean acidification, and widespread marine anoxia, a scenario chillingly familiar to Anthropocene listeners. And again, we can talk about some of these in more detail later if you like. Students sometimes ask me if I worry about the possibility of the Yellowstone caldera exploding in another super volcano eruption. As a geologist, I know that could happen someday, but the probability in our own lifetimes is very low. But as someone who delves daily into the deeper rock record, I do lie awake at night worrying about the magnitude of our perturbations on global biogeochemical cycles. The growing dead zones in the oceans, like in the Gulf of Mexico, Chesapeake Bay, and the Baltic Sea, caused by vast overabundance of nitrogen, mainly from fertilizer runoff, looks awfully similar to the story told by sulfidic black shales in the Permian extinction. And of course, the big elephant or element in the room is carbon, namely our non-looping, uncompensated, one-way injection of it as CO2 into the atmosphere. Anthropogenic carbon dioxide emissions, which now outpace those of volcanoes by a factor of more than 50. An unjust fact about carbon emissions is that while one part of the world, the US and Western Europe in particular, has been responsible for a disproportionate share of the output over the last century, the whole world suffers the consequences. This is because the mixing time of the troposphere, the lower part of the atmosphere, the time it takes for turbulent stirring by winds and weather to homogenize the air on a global scale is relatively short compared with the residence time of carbon in the atmosphere, which is a century or more. if the mixing time were long compared with the residence time, then CO2 would hover close to the surface, close to where it is released, like garbage piling up when trash haulers strike. And that might motivate action to emit less. But because our individual emissions are not only invisible, but conveniently dispersed around the world, we have felt little incentive to curtail them. A tragic irony is that our CO2 emissions, by increasing ocean acidification, are also slowing Earth's long-term carbon sequestration process, namely the formation of carbonates like limestone. And much of this is actually biogenic limestone. These are the heroes of the planet, coccolithophores, which are one of the main organisms that sequester volcanic carbon dioxide over time, lock it up in mineral form as calcite, and store it in rock form over the long term. Without these little organisms doing that ecosystem service, Earth would be a runaway greenhouse planet like Venus. And this is a little bit complicated depiction of that process. This is the Earth's long-term carbon cycle. It's probably one of the most important chemical equations that govern the way the Earth works. So very, very briefly, this is a simplified version of what I'm talking about. Carbon dioxide in the atmosphere, actually combining with rain, forms a weak acid, which can act on silicate rocks. This is what this represents. Dissolve the constituents of those rocks, carry them to the sea, where they are ultimately precipitated as silica, and importantly, calcium carbonate or calcite, the main ingredient in limestone. And over geologic time, the amount of CO2 emitted by volcanoes is about balanced by the amount of CO2 fixed by tiny little marine organisms as calcite that then becomes limestone. And by increasing the CO2 in the atmosphere 50-fold over the last 50 or so years, we have very severely disrupted the balance in this cycle. And as I said before, because we're increasing ocean acidification, actually decreased the amount of calcification that is happening by small organisms. So we've increased the input into the atmosphere and we've decreased the output from the atmosphere. And our perturbations of the carbon cycle are only one way in which human activities are now completely out of pace with Earth's own rhythms. And here's a list of some of the criteria or the arguments for the Anthropocene, this idea that we have crossed a threshold sometime in the last century in geologic time to merit the designation of a new epoch on par with the Pleistocene and the Holocene. And again, we could talk more about some of these different things in addition to the truly outrageous acceleration of greenhouse gas emissions. In our culture, we tend to mistake technological prowess for wisdom. The people we call visionaries base their conceptions of the future on the notion that we should do everything in our power to circumvent the irksome constraints of the natural world that have shackled hapless denizens of the past, not appreciating that Earth is so much more powerful and more patient than we are and will always prevail. The idea that Earth time just doesn't apply to us leads to the delusion that we can outsmart the complex system of biogeochemical cycles and, for example, solve our climate woes through stratospheric sulfate injection and expect that there won't be a powerful backlash of unintended consequences. I don't know if people get the New York Times, but just yesterday there was an op-ed by David Keith, who's at Harvard, advocating for this idea of solar geoengineering, which I think is a very Faustian bargain. Again, maybe something we want to talk about in the discussion. Disrespect for time also seduces us into thinking that we could skip over all that inefficient millions of years of coevolution stuff and just terraform ourselves another planet. Engineering the climate or terraforming Mars sound easy if you're completely unaware of the intrinsic timescales of geological and biological phenomena, the deep evolutionary pathways that gave rise to the world we live in, the intricately choreographed behind the scenes biogeochemical cycles, the housekeeping crew that make Earth habitable. Such ideas are beyond hubris, revealing not only a profound ignorance of the Earth, but also of human nature. What makes us think we could successfully change the rules that govern this or another planet when we haven't even learned to govern ourselves? Anthropologist Clifford Geertz famously defined culture as the constellation of stories that groups of humans tell themselves about their place and purpose in the world. In Western culture, with its Abrahamic underpinnings grafted to principles of social democracy and capitalism, the stories we share about who we are largely exclude the natural world. Nature is at most a passive backdrop, the scenery against which the real stories unfold, not a central protagonist in the narrative. Well, very soon now, the scenery is going to start directing the play. Long-term thinking and planning are absolutely essential to grappling with the intractable issues of our time: climate change, intergenerational poverty. Yet just when that is most acute, our attention spans are shrinking. Our political and economic infrastructures have few mechanisms for sustained action over timescales needed to resolve our most intractable problems. Government is increasingly hamstrung by the 2-year congressional cycle, and corporate decision-making is yoked to good annual or even quarterly reports. As individuals, we hardly have time to look up from our beloved phones. Increasingly, the only institutions that can act on intergenerational timescales are authoritarian governments or foundations underwritten by the super wealthy. While the actions of many of these organizations may be laudable, they are also fundamentally undemocratic. We need to re-democratize the future. When we peer into the geologic future, a paradox emerges. To some extent, we can see what lies in the far distance more clearly than what is in the foreground. The sun, as a G-type star, is about halfway through its life expectancy, and in 5 billion years or so, it will enter its red giant phase, engulfing the Earth and other inner planets. 3 billion years before that, however, the sun's increasing luminosity will lead to an extreme greenhouse effect from the vaporization of the oceans. Once the planet's water is lost to space, the carbon silicate weathering system that I showed you that has acted to sequester volcanic CO2 over time will shut down, creating an even more intense greenhouse state that would likely make surface conditions intolerable for all life about 2 billion years from now. For at least the next billion years or so, though, plate tectonics will continue to shuttle continents to new positions around the globe. The Atlantic Ocean will begin to close, and in about 250 million years, the Americas will be reunited with Europe and Asia in a new supercontinent that has already been named Pangaea Ultima. Meanwhile, rivers will have erased the Himalaya, Alps, and Rockies. In about 80,000 years, the Earth will reach the point in its orbital cycles where another ice age could happen, but this will depend on greenhouse gas concentrations, ocean circulation, the state of the biosphere, and many other variables. The next 1,000 years, the same amount of time that separates us, say, from the Viking Age, are even harder to bring into focus. If human emissions, carbon emissions have not been sharply curbed and powerful positive feedbacks in the climate system are activated, the Earth could experience a replay of the Paleocene-Eocene thermal maximum 55 million years ago, when temperatures spiked by 8 to 10 degrees. If this happened, marine and land-based ecosystems would be stressed to the point of collapse. Sea level would rise tens of feet, inundating many of the world's most populous cities. Altered weather patterns, more ferocious storms, longer and deeper droughts would stress world food production. Increasing proportions of government budgets would have to be channeled into crisis management. The balance of geopolitical power would shift depending on how nations fare in the new climate regime. But none of this is preordained. We have the power to write a different saga for the coming millennium. Rather than lapse into existential despair that we won't be here in a billion years, let us reclaim at least the next few centuries. It is empowering, or at least therapeutic in these dark times, to imagine what a time-literate society might look like. In his last public interview, Kurt Vonnegut said, "I'll tell you, one thing that no cabinet has ever had is a secretary of the future, and there are no plans at all for my children and my great-grandchildren." So let us adopt Vonnegut's suggestion as our first proposal, a representative for the yet-to-be-born to serve among the top advisors to the president. The Department of Future would set in motion a realignment of priorities in all aspects of society. And I feel here we should cue some very triumphant music that rises in volume slowly. Resource conservation would again become a core value and a patriotic virtue. Tax incentives and subsidies would be rebalanced to reward long-term stewardship over short-term exploitation. Putting a price on carbon might help us get a grip on our fossil fuel addiction, sober up, and let us prepare for natural disasters that will happen without our assistance, like the hundreds of large earthquakes that will happen in the next century, rather than expending resources on self-created climate catastrophes. Poverty and class-based disparity of opportunity would be recognized as problems with deep historical roots that cannot be solved without sustained commitment over commensurate timescales into the future. Public school teachers and others whose work represents an investment in the future would be paid well and held in high esteem. Geology would be fully integrated into science curricula, perhaps serving as a capstone course in which students would apply concepts of physics, chemistry, and biology to the immensely complex Earth system. With a solid understanding of how the planet works, students would go on to become educated voters who would hold public officials accountable for wise governance of water, land, and air. Legislators, governors, and mayors who embrace the 7 generations principle would point proudly to what they are working toward and be reelected by grateful constituents. I believe, perhaps naively, that if more people could experience the understanding of Earth's story and see themselves primarily as Earthlings with a common past and shared destiny, it might spring us out of the polarized and entrenched ways of thinking about the world that we're trapped in. As a geologist, I've worked with people from all over the world, from very different cultures and generations older and younger than mine. The strong human connections I've developed with them through our shared study of Earth makes me optimistic that a geocentric worldview might help us overcome the animosities and barriers that divide us and get down to work on things that really matter. Collective awareness of Earth's story might save us from environmental hubris. Understanding how historical happenstance is written into each of our personal lives might cause us to treat each other with more empathy. And a timeful habit of mind might even make us less neurotic about the fact of our own mortality by shifting our focus from the finite lengths of our lives to the rich anthology of experiences that a lifetime represents. While other senses may be dulled with age, the sense of time, which can only be developed by experiencing it, is heightened. Growing old requires one to shed the illusion that there is only one version of the world. As a technological society, we have an almost autistic relationship with the Earth. We are rigid in our habits, savants when it comes to certain narrow obsessions, but dysfunctional in many other regards because we wrongly view ourselves as alone in the cosmos. Believing that nature is something outside us, a mute and immutable thing external to us, we are unable to empathize or communicate with it. But Earth is whispering in our ears all the time. In every stone, it offers an eternal truth or a good rule of thumb. In every leaf, a prototype power station. In every ecosystem, a model of good urban planning. In every watershed, an exemplar of a healthy economy. We need to view ourselves as citizens of Earth, this still an evolving tangle of old, recycled, sun-powered, and profoundly interdependent dancing parts. There's a teaching attributed to the 18th century Polish Hasidic rabbi, Simcha Bunim, that for me, a lapsed Scandinavian Lutheran, carries great wisdom. And it goes, one should always carry 2 slips of paper in your pocket. In the left, one that reads, I am ashes and dust. And the other, in the right, the world was made for me. Both are true. And that's what rocks have been trying to tell us all along. Thank you.
Bravo. That was wonderful. I have some questions, but I'm going to hold mine for give everybody else a chance to raise their hand and be heard. Let me open this up to the gallery. Attendees. Gallery, there we are. Should work. Maybe I need to cut back to this speaker and then try again. Gallery. I think I need some help here to open up the gallery so we can see the attendees.
You know, Richard, I'm not positive we can do that with the webinar format.
Really?
Now that I think about it, have you been able to do that in the past?
Not that I can recall with this group, I guess. Yeah. Thanks for clarifying that, because I've been working on the view and trying to reduce us and putting it as attendee view gallery, and it's just not coming up.
Yeah, I think it's because we're in that format.
We are. Okay, well, thank you for that advice. We have 3 attendees, I think, with their hands up. Let's try some questions. Steve Shellen is asking the structure of the Earth and how it changes and changed over time.
I think he was responding there to
okay.
my initial question, what is geology? And again, good answer. That's
so
certainly...
it is. So it is. Okay. We'll try the chat function. Here's a question from Mary Jane Curry. Is any geology taught in the schools? The indigenous concept of 7 generations thinking would really benefit all citizens?
So yeah, two questions there. There is some earth science, and there has been for a long time in Wisconsin science standards, and I think this is typical nationwide in the 8th grade. You know, and our public school teachers, I respect them very much, but in general, people don't have much background in earth sciences. They may be primarily trained in other sciences, and they're teaching the earth science course as sort of an extra. There certainly is, it's the exception rather than the rule at the high school level to have rigorous earth science. Most of the students, in fact, who enter university, both at Lawrence and UW or wherever, who end up majoring in geology, come into the field almost by accident. And that was true for me. I had no understanding that geology was a really academically rigorous and engaging field. There's just we have a PR problem, as I said at the beginning. So unfortunately, no, there's not much really modern, engaging, rigorous earth science taught at the high school level. There's no AP test in geology or geoscience, for example. There is environmental science, but the earth sciences are woefully underrepresented. Some enlightened high schools do actually have people in their science staff with backgrounds in the geosciences and do offer some upper level courses, but quite often these courses are for the kids who are not going to college. And they too need to learn about Earth, but it sends a message to the ambitious and academically talented kids that you don't want to take that class. That's not really science, and that's really tragic. I would say this is the science that all Earthlings urgently need. And certainly if we could instill in everyone the 7 generations idea, that if we just had a habit of mind of thinking, what are the implications of our actions today? You know, at least 3 generations in the future, we would be so much better off.
Very good. Another question here. What would motivate the seemingly self-centered human nature to allow a geocentric worldview?
Well, and you know, I'm not a sociologist or a psychologist, but I know, again, from my personal experience, that my understanding of my place on this planet gives me some kind of existential comfort. And I think if we could graft that kind of approach to the science, it would be more engaging to more people. You know, I've been on the book circuit and the lecture circuit for a while with this book and other writing I do. And I've come to realize that what we fundamentally need is a cultural shift. It's not going to be just about science. We somehow have to leverage fundamental changes in the value system. And that sort of change is the hardest sort of change. We can nudge it along with economic incentives, like a carbon tax would change people's habits overnight, and then that would be a way that values could get realigned. But ultimately, it's not science that's going to save us, despite my subtitle. It's a deeper cultural shift that has to happen. And on my good days, I'm optimistic that it might.
Here, I can understand that. A lot of good questions here. I'm really pleased with you folks. Wow, what a pile. Let's see.
Yeah, lots.
I don't want to miss anybody, but
I can see them too. I can quickly.
There's one here. Is the altered calcite cycle responsible for the bleaching and death of coral reefs?
Yes, in part. The bleaching is partly due to changing temperatures. I think some corals are not able to tolerate shallow sea temperatures above a certain point, but also the difficulty of extracting the calcite and making the calcium and making the calcite is part of the story too. That they need this exoskeleton to live, the little coral polyps. And as the ocean acidifies because of higher CO2 levels, that gets harder and harder. And yes, definitely. And we see this also chillingly in past extinction events, where ocean acidification led to widespread die-offs in reefs.
So basically what you're saying is that pH is very much important along with temperature.
Yes, yeah.
Okay.
And by the way, that's one thing that would not be changed if we did the very Faustian bargain of doing sulfite aerosol injection into the stratosphere to cool things off. Meanwhile, ocean acidification goes on unabated.
Exactly. Exactly. Yeah, the whole idea of geoengineering is so infantile in many cases. I just saw in this morning's news that the ozone hole over Antarctica is getting bigger now. It's larger than Antarctica itself. And so we need to get back to focusing on the other chemicals in our environment as well as CO2. Thomas Newman asks, do you have an estimate of when methane hydrate will reach a crisis point?
Yeah, so first I should explain, methane hydrates are relatively newly discovered, like starting in the 1980s. We didn't even know these things existed until ocean drilling started turning up weird icy versions of methane deposits in the deep seafloor. And these have the potential to become unstable and belch out of the oceans. And methane is a very potent greenhouse gas, many times more potent than carbon dioxide. And this is one of these potential runaway positive feedback processes, positive not because it's good, but because it's self-amplifying, that could happen with climate change. So there are the methane hydrates in the seafloor. There are also huge methane stores in tundra areas. I don't know if people have seen pictures from Siberia the last couple of years, both of these sort of zombie fires that are burning, and also pits that have been found after the fact by methane, either again kind of belching out of the ground or being released and then causing the collapse of kind of sinkhole-like areas. And so these are greenhouse gases that are stored in different forms as ices or in undecomposed organic matter in the tundra, and could again be reawakened by warming and then become this runaway train. These are not emissions we could control. These are not our own direct emissions. They're just sequestered forms of organic matter that could become released with warming. And those do cause me to lie awake at night. I've done a lot of my work, as Richard mentioned at the outset, in the high Arctic, in Svalbard and in Ellesmere Island. And, there's a lot of peat up there that's kind of in a metastable state left over from, the last 10,000 years or so. And if that stuff starts really decomposing or deteriorating, we're in for a bad few centuries. I don't know. I would hesitate to put a year on it, but if we don't act really soon, I would say by the end of this century, we might be at a tipping point where we've activated those positive feedbacks.
Yeah, indeed. Thank you for that reality. There's the next question seems to be an answer. Anti-abortionists and climate deniers. When one puts those two together, one thinks of an answer rather than a question. And maybe that's an answer to problems with the our planet evolution. The next one, let's go to a question. Since our current young population is captured by the electronic media use in all aspects of life, is there any thought to preparing a geology set of classes where this approach is presented in courses, games, and media art?
Yeah, and because of this really urgent need to educate Earthlings about the way their planet works, many of the professional organizations, the American Geophysical Union, the European Geophysical Union, the Geological Society of America have finally been doing better outreach efforts and have sort of organized initiatives to do exactly these things, to try to find ways, even though the geosciences are not well represented in curricula, formal curricula, to make some of this material accessible and engaging. And so it's coming, it's happening.
Good.
But again, changing school curricula is really hard. There's a lot of inertia behind it.
Yeah, so true. From a social justice perspective, I think this might be coming from Canada. Would you please address the privilege issue of having the time to think like a geologist? And then it answers, my geologist son asked me to ask you this.
Okay, well, when I talk about thinking like a geologist, it's this polytemporal habit, this idea of seeing not just what is on this current plane of time that we inhabit, but understanding something of its past and its future. So that's the habit of mind I'm talking about that I think is critical for motivating action on environmental issues. And I don't know that it's a privileged position. And again, I fully admit the culpability of my field in all kinds of environmental sins in the past. But this habit of mine that I call timefulness, of understanding that we are living in geologic time, that there will be consequences of our actions far into the future. I don't see that as a privilege. I'm trying to argue that this is a very powerful worldview that can shift our understanding of who we are. So I'm not sure if that answers the question. And I would say that we, in embracing that worldview, we can address many of the social justice issues we have, that we need to just get in the habit of long-term thinking. Everything about our culture is about short-term payoff.
Those are good questions and answers. These are related. Mary Jane Curry asks, what values should we all strive to shift to? That is, I imagine, more environmental friendly values about how long before oil and gas reserves are depleted.
Well, again, these values that I'm talking about is reconceiving ourselves of who we are. And the hubris, I guess, of thinking that we can outwit nature is part of the problem, is appreciating the power of nature over time, and really kind of tuning our technologies to it. That's the kind of value that we should be embracing. The second part of the question, it's interesting to me. I've been in geology long enough. When I was a student at UW-Madison, climate change was kind of just on the horizon. People were starting to talk about it in the field. And there was this idea that oil and gas were soon going to be depleted, and that would kind of just necessitate a shift to other energy sources. Well, 35 years later, we have better technologies for exploiting oil and gas, including hydrofracking and deep offshore drilling. And the general consensus among scientists is that we will fry ourselves with global warming long before we ever exhaust oil and gas. We can find more, there's more out there. We just don't want to burn it. It better stay in the ground. So yeah, I think that's the general view these days.
Good point. Does geologic history contain data on global temperatures versus time?
Absolutely. So there are different kinds of levels of resolution of climate records in ice and in rocks. So the highest resolution climate records we have that go back as far as about 800,000 years, almost on an annual level, maybe decadal when you get to the really old ice. So ice cores provide nearly annual records of temperature as well as atmospheric composition back 800,000 years. Before that, the next most high resolution record of climate and environmental conditions around the world would be deep sea sediment cores. The sea is the sea floor off the continents is a very quiet environment where all that happens is the settling of very fine particles and biogenic material. Over time, there's no disruption. So if you core down through those sediments, you have a quite complete and uninterrupted record going back about 170 million years. That's the oldest ocean crust we have. So we have really very good handle over the last 170 million years or so about what the Earth's climate has been. Then the rock record is not quite as high resolution because ocean floor gets subducted. We don't have ocean floor that's pristine like that, that's older than that. Here and there in mountain belts, we can see bits and pieces of it. And other rocks, like the stratified sedimentary rocks we have in Wisconsin, tell a kind of crude, not high resolution story of climate change over time. But certainly the last 170 million years, we have a very good sense of the relationship between, say, greenhouse gases and ocean pH and temperature that can be gleaned in a lot of detail. And that's a whole, I can't answer that question without, kind of launching into a mini lecture on paleoclimate, but yes, is the short answer.
We can go on here, and I'm not sure. I think there are probably some more questions out there. Let me ask one now, pertaining to 60 Minutes a week ago. We had Elon Musk on. I don't know if you happen to see that program.
I mean, I know of Elon Musk, of course.
Sure you do. Yeah. I guess my question is, if you had Elon in your class, and at a young age where he might be more amenable to guidance, and yet you knew ahead of time what his potential might be, what advice would you give him about Earth versus Mars, about directing his talents in the best way he could for humanity?
Well, he's clearly a smart person. And I mean, I guess, on the one hand, he's developing electric cars. He's kind of pushed that market. So I think that's basically a good thing. Although I think we are also glomming onto electric cars as the panacea. There are going to be environmental consequences with that, with all the mining that's going to need to be done. Anyway, I would, instead of trying to lecture him, I would hope he would have the patience to really delve into the field. And I think anybody who has a real understanding of the immense complexity of the Earth system will come to the conclusion that it's completely absurd to think that we could, by fiat, kickstart these biogeochemical cycles on Mars and in anything like a few generations ever, have a habitable environment. It's just so insane. It reminds me of, kind of cartoonish villains in movies, megalomania on the largest scale. It's just breathtaking to me. I'm not against space exploration. I watch with fascination as information comes back from Mars, from the robotic rovers and from the orbiting satellites. But it just shows such an ignorance of evolutionary pathways that gave rise to the system of biogeochemical checks and balances that we have. You can't just implement those. They have to mature over very long timescales, and timescales far longer than humanity has ever been able to cooperate on. I mean, the only example, I sometimes say that, is there ever a project that humans have collaborated on over many generations? And some people say, well, cathedrals. Okay, that's true. Although a lot of that labor was probably slave labor and indentured servitude. But I mean, this would be a project that would have to take millennia. It's completely insane. And the argument he makes that, well, we have to preserve humanity in case a rogue asteroid hits. The impending catastrophe of climate change is so much more probable,
Yes.
so much more. And we know it's coming. Pour all of those billions of dollars back into averting that, please.
Thank you for that. It's a thought that's been in my mind, and I'm glad to have a geological professor say those words. I think it's like a club of wealthy people who want to make a little private golf course or something like that.
Well, can I share maybe
yeah, please do.
a personal anecdote? So I gave a talk for Stuart Brand's Long Now Foundation. So Stuart Brand, people in this group might remember him in the 70s as kind of the guru of living off the grid. He did the whole Earth catalog.
Right, we had him here in Medicine a while ago.
Yeah, and I respect what he's done. So I knew of the whole Earth catalog as a child, and we had it in our house. And like one day I got an email from Stuart Brand, and I ended up giving a talk at his Long Now Foundation in San Francisco. Sadly, he was not actually there the day that I was there. He was in the UK celebrating James Lovelock's 100th birthday, which that was a good excuse. But anyway, so I gave the talk, and I mentioned briefly, this hubris of terraforming Mars. And then they took us out to eat. My son actually came with me and took us out to eat. And at first, I was just in awe. We went to this amazingly fancy restaurant in San Francisco, and these very prominent Silicon Valley people were at the dinner. And they started talking about their ideas for terraforming Mars. And I was like, didn't you listen to what I was saying? I was just aggravated at first and tried to interject. And then very soon I realized, oh no, this is what they do. They're sparring. It's this very macho, trying to outdo each other with their technological prowess. And after a while, I started just feeling like I was at a table with completely insane people. I mean, I shifted from being in awe of them to being afraid of them. It was really quite a terrifying thing. I just like, these people have a lot of power and a lot of money, and they are completely insane. So, yeah.
we do have a lot of preconceived fears and prejudices. And now I'm going to ask you one that you probably knew is coming. I know the class know it's coming. And that is, it relates to a table that you might not have seen by Professor Wade Allison at Oxford. But he has an interesting table where he has the fossil fuels down the middle of the table. In the right-hand column, he has nuclear power, and on the left-hand column, he has the renewables. And he looks then at the energy density and notes that as we move away from fossil fuels to renewables, we go down about 4 logs in energy density. And if we go to the right column on nuclear, we go up about 7 logs in energy density. Given that and the intermittency of renewables and its dependence upon methane as backup, mostly, what are your thoughts about nuclear energy in general for the future and helping us to get off of the fossils, and in particular, as it might relate to Wisconsin, but let's start with in general.
Well, I've come quite a ways from my earlier thinking about nuclear, and basically I do think it needs to be part of the solution. And I know some people probably don't want to hear that. The main problems for this country are mainly political. I mean, we had for 20 years a possible long-term high-level nuclear waste repository in Nevada, the Yucca Mountain Project. And then because of political pushback, that got indefinitely tabled. It's not going to happen. We have no long-term plan for high-level waste, and we need to figure that out if we are going to go back to nuclear. It's unfortunate that Fukushima Daiichi, that plant in Japan, that should not have been sited on the coast in a tectonically active area. But in general, I think nuclear power can be safe. There are other countries that have solved the long-term storage problem, France, for example. And so I think it's got to be part of a menu of strategies, which should be topped by efficiency and cutting back in total energy consumption, which is something people don't like to talk about. Yeah. So there's not going to be a silver bullet. And I think, again, nuclear is going to be part of the answer, but we haven't grappled with the reality that if you're going to have nuclear power, then you're going to have high level waste and you have to do something with it. So, yeah.
Thank you for that. Kathy Berman says, I love being referred to as an earthling. Maybe just that small change in nomenclature can make us shift our thinking to a more timefulness perspective.
Thanks, Kathy. I think so. And maybe I'll make a shameless little plug for a project I've been involved with through the Center for Humans and Nature in Chicago. I don't know if people know of this organization. It's a wonderful one. It's based in Chicago, but it's really national or even international in its scope. And they've just put out this lovely little box set called the Kinship Project. And it's got 5 little volumes. I was the contributor of one. Among other people, Robin Wall Kimmerer is an editor. And I have a little piece called Becoming Earthlings. And I make exactly this point, that it's just a shift in our understanding of who we are that I'm calling for. And I do think that's potentially powerful. It's got to go along with other things too. But if we could just step back, then we have more empathy with each other. We're all Earthlings. And we share this verdant planet with a lot of other kin. So this idea of kinship, I think, is on the ascendancy, and being an Earthling is part of that.
Good. Are there other hands up? I see a new question. The structure of the Earth and how it changes and changed over time.
Again, I think that's his response to my first question about what is geology? Yeah.
And the threats to our society. Okay. All right. Any other hands raised?
I see Lewis Harnish said that the idea of the Secretary of the Future, and I see the connection maybe that he was making before. I wanted to mention actually that I learned quite recently that the provincial or the regional government in Wales in the UK actually has a Secretary of the Future. And so they are, not a national government, but this person is charged with being the sort of advocate and representative of unborn future Welsh citizens. And so anything that's proposed, a new major highway project or anything, needs that person's analysis and approval before it can go ahead. And it's such a simple thing.
Yes.
Someone who's always there thinking a few generations out.
Nice. Very nice. Any other questions out there? If not, I will make a comment about just about next week. We're talking about, it's going to be about recycling, and Tony Preza, our co-chair, will be talking to help us deal with a COVID issue that made it impractical to do a field trip next week. So he's going to be giving an expanded talk, and recycling. I think his theme is let's think about recycling a lot more, and perhaps thinking of perhaps generating less plastic in our packaging, so we don't have so much to recycle. I would imagine that he'll be encompassing a lot of interesting topics, so I encourage you to attend. And I must say to you, Marcia, I really appreciate your talk today. It rose above your book, Timefulness, which has a lot of fascinating detail, but you took it up another plane to make us think in a timeful way. And I really enjoyed it, and I'm sure our whole class did too. So I want to thank you so much for coming on and sharing your thoughts with us today.
It was really my pleasure. Thanks for all the great questions. Very insightful.
Yes, we have a curious crowd that I think lives up to the concept of PLATO, participatory learning and teaching. And it will be nice one day when we can meet one-on-one and not have to deal with the questions in quite such a fragmented manner. But then again, we might not have you coming down to Madison, or might have to plan it a little more carefully to have you come here. But anyway, it was wonderful that you spoke with us this way today, and thank you very much.
Thank you. Bye-bye.
Okay, bye-bye, everyone, and we'll see you next week. Thank you very much, Stephanie.
Hi, you're welcome. What a wonderful presentation.
She is good. Yes, she really. I didn't know. I couldn't imagine how she could take a 150-page book and put it into such an elegant 50-minute presentation. It was really lovely.
Yeah, absolutely, absolutely. I'm going to check out that book. Yes. Could you make me a co-host or a host? Because I think, or could you stop the recording? Do you know how to do that?
Oh, if I just end it, I think it will, but let me try to.
You know, why don't you make me the co-host? Because I want to make sure
okay.
I get the recordings accurate.
Sure. I've got to look at how to do that.
Remember?
Down by participants?
You got it. Yep. So if you see my name under the participants block, if you do the drop down box under more.
I've got you there now as a panelist.
Yeah.
There I can put more under host. Can rename you or something like that. I'm not quite sure.
You see where there's a little box that says more and there's a drop down?
Yes.
Oh, does it just give you rename? It doesn't give you any other options?
It just says enter new name here. So I'm going to type in your name.
Oh, no, that's okay. I think it's okay. I grabbed the YouTube link, so I have that. If you, yeah, perhaps you could just end the recording. Do you see where it's recording on top?
The and then whoever records can wipe off this end. Whoever posts it.
And that'll be me. I'll be doing all the editing. So
good.
I'll be
Thank
sure
you so much.
to edit the beginning and the end.
All right. Well, it's been just great, Stephanie. See you next week.
Yes, absolutely. Have a good week.
Excellent. Thanks so much. Bye-bye.